Okay, give me 1 second. Let's just set this up. Okay, so this says the population of values has a normal distribution with mu of 27.5 and sigma 23.6. You intend to draw a sample of size 126. Find the probability that a single randomly selected value is between 29.6 and 30.2. So I'm going to start by just drawing a normal curve down here just to kind of help us figure out what we're looking for. That's good enough. 27.5 and right in the middle. 23.6 is our sigma. I'm looking for the probability that something falls between 29.6, which will be somewhere over here, and 30.2. Doesn't have to be exact, but just an idea of what you're looking for. So I'm looking for this area. Okay, so that's just going to be a straight up calculator plug and chug kind of thing. I'm going to go to second distribution. I'm going to do normal CDF. Okay, so when you have the x values and you want to find the area between them, you're going to do normal CDF. If for some reason we have the percentages and we want to go backwards and get the values, we'll use inverse normal. But we're going to use normal CDF. And now it just wants our lower and upper bounds. Just plug in the lower and upper bounds of this section, 29.6 and 30.2. My mu is 27.5. 23.6 is my sigma. So I get a value of 0.01009. So we'll say 4 decimal point 0.01009. I guess we'll just do it like that. Doesn't have a 4 decimal places, yeah. So this looks like it would be 0.0101. Okay. This says stuff about z-scores. You don't have to worry about finding the z-scores. That's if you were going to do it by hand or with like a z-table, but we have the calculator which will do it for us. Okay, question 19. Scores for a common standardized college aptitude test are normally distributed with a mean of 508, standard deviation of 95. Randomly selected men are given a test preparation course, yada, yada, yada. If one of the men is randomly selected, find the probability that his score is at least 543.6. So, if you want to draw the normal curve, it is a good place to start. Draw the curve here. Mean is 508, standard deviation 95. 508. Sigma is 95. So it says, what's the probability that he scores at least 543.6? 543 is somewhere over here. So I want to know the area above it. Just want to double check. 543.6. So, back to my calculator. Normal CDF. My lower bound now is 543.6. There is no upper bound. This goes on forever. So to write that in the calculator, just pick a really big number. I don't know, whatever. That's good. What is it, 1 million, 10 million, something like that? Doesn't matter. Just make sure it's above like 100,000. 5082, sigma is 95. Enter, enter, enter. We get 0.35392. 0.3539. Now notice your answer. Notice this answer. Yours is the complement. So I think you actually found the probability that x was less than 543.6. So instead of going from some negative number up to 543.6, you should have done 543.6 up to a really, really large number. Okay, for the next part, it says if 16 of the men are randomly selected. So from the notes and the lecture videos, you should remember that if you're talking about a sample, all that's going to do is change our standard deviation. So if our sigma is normally 95, if we're talking about a sample now, it's going to be 95 divided by the square root of n. So 95 divided by the square root of 16, or 95 divided by 4. That just changes our sigma. So you can write it as 95 divided by the square root of 16, or just 95 divided by 4. It doesn't matter. And nothing else is going to change, but we get a probability of 0.0669. Okay, if the random sample of 16 men does result in a mean score of 543.6, is there strong evidence to support the claim that the course is actually effective? So this says if I pick 16 men, their average score is a 543.6. So what are our choices? Yes, the probability indicates that it is highly unlikely that by chance a randomly selected group of students will get a mean as high as 543.6, or no, the probability indicates that it is possible by chance alone. So do we believe this is a reasonable chance? Okay, so eventually we'll be given a standard. We'll say, all right, the standard is if it's above this value, we say it's unlikely. If it's below this value, we say it's likely. So in this particular case, if I pick 16 men, the chance that their average score is at least a 543 is like 6.69%. That seems pretty unlikely, right? I believe anyway. Pretty unlikely. So it's unlikely by chance alone that their scores are this high. So if I pick 16 men and the results are that high, I would assume it's not just based off of luck, it's based off of something more than luck, like their skill. So we would say that the course is effective. Because if I just randomly pick 16 people, the chances that their average score is this high is not very good. So we have to take chance out of it and say, all right, then this course must be doing something beneficial, because by chance, it's not very likely that I would pick people with that high of a score. Okay, and then the last one, a real estate group in New York reports that the mean monthly rent for a one-bedroom apartment without doorman in Manhattan is, $2,608. Good thing we don't live in New York. Assume the standard deviation is 496. A real estate firm samples 92 apartments. Sample. What is the probability that the sample mean rent is less than $2,644.20? I think you might have done the reverse again, but this is the probability that the sample, we'll call it, I don't know, apartment, we'll say A, is less than 2,644.20. So the thing we have to keep in mind is, since we're talking about a sample, we have to change our sigma. Distribution, normal CDF. The upper bound, we're looking for something being lower than that. So our upper bound is going to be 2,644.20. Our lower bound is going to be I flipped them. The lower bound is going to be some really big negative number. Our upper bound will be 2,644.20. Our mean is 2,608. And our standard deviation is 496 divided by the square root of 92. So I can write it just like that. So you'll see I get an answer of 0.7580. Whoops. Which is just the complement of what you had. So again, I think you actually found the probability that the sample would be larger than that, which is good. You were very, very close. Just one small little error. But the rest looks really good.